Okay, in section 3.1, the first part, we solve systems using graphing. We are now going to look at algebraic methods, substitution and elimination. These are methods that you have seen before in Algebra 1 and in geometry. We're going to start with substitution. The process that we will follow is to solve, substitute, and then evaluate. So the first solve will incorporate solving for one of the variables. As I look at this system, the easiest variable for me to solve for is that x, because the coefficient is 1. And that's a pretty good rule to follow for substitution. If you have a variable that has a coefficient of 1 or -1, anywhere within the system, it's pretty easy to solve for that variable. If the coefficient is something other than 1 or -1, you could still solve for it, but there could be a chance that you end up with fractions, which can make life a little more complicated. All right. So that's a general rule that I tend to follow if I have a choice in terms of how I would solve a system. So this would be a good one to use substitution for. And what I'm going to do is solve for the x. So to solve for x, I'm going to move this 2y over. So I will end up with x equals -2y plus 1. If you want, you could also write that as 1 minus 2y. So after we solve, the next part is to substitute. So I know that x is equivalent to -2y plus 1. So what I can do is take that -2y plus 1 and substitute it in for x in this other equation. When we do that, whenever we plug something in, I would encourage you to use parentheses. So now, instead of having 5 times x, I now have 5 times -2y plus 1 when I substitute that in. From there, the next part of the process is to solve. All right, so to solve this, we would first distribute the 5 through. That takes us to that next step. From there, we would combine like terms, the -10y and the -4y. So that'll leave us with -14y equals -28. I also subtracted 5 from both sides to make that happen. And then solving for y from that point forward, you will get 2. So that takes care of the second solve. And now the next part of the process is to substitute again. So we will substitute y back into either the top or bottom equation. Actually, the easiest spot to solve for, if you're confident that you solve for the variable on the front end, is just to go right into the equation that you solve for the variable, because we do want to find what x is. So if we plug that 2 in, we would have -2 times our value of y now of 2 plus 1. And if we simplify that, we get x equals -3. So the solution for our system would be -3, 2. If we were to graph both of those lines, they would intersect at that point, -3, 2. Make sure that you list your x value first, your y value second. A second example, we want to solve a system utilizing elimination. Elimination is, just like it sounds, what our goal is to do is to get one of the variables to eliminate. So in this problem, you have a choice. You could either eliminate x or y. It is up to you. However, as I look at this, if I want to get them to eliminate, the coefficients in front of the variables have to be opposites. And when I say opposites or total opposites, it means like if one of the coefficients is 2, the other one has to be -2. All right, we got to make that happen. So as I look at the x's, I could definitely get those to eliminate by finding a common multiple. But they're both positive. All right, in order for them to eliminate, one has to be positive and one has to be negative. So I would probably eliminate the y's in this case because one is already positive and one is already negative. So I won't have to deal with multiplying through by negatives. If we can avoid that, that's probably a good idea just because it will allow us to hopefully minimize our chance of error. Sometimes you won't have a choice. All right, but here what I want to do again is eliminate y. All right, so we need to find a common multiple between 3 and 4. All right, multiples of 3 are 3, 6, 9, 12. Multiples of 4, 4, 8, 12, 16, etc. So the least common multiple between those two is 12. You don't have to choose the least common multiple, but it certainly makes it easier. All right, because you won't be dealing with as large numbers. So I need to make this 3y become 12y. So I'm going to multiply this equation through by 4. So that's going to be the full equation through by 4. I need to make this -4y become -12y. So I will multiply that equation through by 3. And when we do this, the result now is a system that looks like this. We have 20x plus 12y equals 36, and 6y minus 12y, or 6x minus 12y equals 42. We can now clearly see that these y's are opposites, okay? So when we combine these two equations together, we're just going to add them up basically. The y's drop out, and that leaves us with 26x equals 78, and we can easily solve for x. So we know that for our solution for the system, x will be 3. So then the next part of the process is to substitute back in to figure out the value of y. You can plug it into either the top or the bottom equation. All right, so I chose to plug it into the bottom equation, so I took this value and replaced the x right there. So now instead of having 2x minus 4y equals 14, I have 2 times 3 minus 4y equals 14, and we work our way through and solve that. So that will end up being -2 for y, meaning our solution is 3, -2. Graphically, that is where those two lines would intersect. Also, keep in mind you can always check your work. You can plug this value of x and this value of y back into both of these equations, so you can plug it in here and here. Okay, you probably want to include the 4 or 3 there, but you can see if the left side equals the right side. That concludes this video. We will move on into example 7 and 8 in the next video.